But first of all, what is a jet engine? To start to answer this, we go back to the squid, for in the simplest terms, the squid is nature's jet engine, and the way in which it slides over the seabed is no different in principle to the way Concorde goes supersonic 11 miles above the Atlantic. All the squid does is suck in water slowly and push it out again at a higher speed. Suck, blow. The act of forcing the jet of water out in one direction propels the squid in the opposite direction. This is known as jet propulsion and is explained in Newton's third law of motion, which states that every action has an equal and opposite reaction. Isaac Newton was one of the greatest scientific thinkers of all time. Around 1665, he discovered gravity, although probably not by having an apple fall on his head. He wrote about calculus and geometry, light and prisms, and most importantly for the history of the jet engine, he defined the 3 laws of motion. His realization that every action has an equal and opposite reaction explains exactly how a jet engine works, which is why the thrust of a jet engine is now often measured in newtons. The principle of jet propulsion, as demonstrated by the squid and defined by Newton, can also be seen with a child's balloon. Here, of course, air is used and not water. But air and water have similar dynamic properties, and the same principles apply. First, air is forced into the balloon. When the balloon is released, the tension in the rubber pushes the air back out through the nozzle at high speed. And as stated in Newton's third law of motion, this sets up a jet reaction, pushing the balloon in the opposite direction. These basic principles have been known to us for about 2,000 years and were first demonstrated by the classical philosopher Hero of Alexandria. Hero invented the fountain and the pipette, and this little steam engine. This invention of his uses nozzles to point jets of steam in one direction, and the engine then revolves in the other. Hero also